In this presentation, we're going to look at regression ANOVA. Now, what we're going to do here in particular is to use all these various other values to build the ANOVA table. So, example, the number of cases, number of predictor variables, the variance, see how that is related, and also the coefficient of determination. So, first off, what we are told here is that there are 26 cases here. Okay. So n is equal to 26. Now, the degrees of freedom which we would have for the total degrees of freedom would be n minus 1. Okay, so n minus 1 is 25. Okay, so starting off pretty well there. The other degrees of freedom are p as number of predictor variables, and we can see it there, and n minus p minus 1. So the number of predictor variables there is 3. N minus p minus 1. Well, first, you could tell pretty quickly that they have to add up to 25, so 3 and 22. But n is 26, n minus p minus 1 is 26 minus 3 minus 1, that is 22. So that it checks out. Okay. So that's a good start. Now, the next thing we have to do is, well, that's this technique. That's all the information we're going to use from those two now. So the next thing is the variance of the response variable is 14. So I'm going to go to a new page here. Now, this is something you should always remember. Variance of the response variable is, particularly with regression to any ANOVA procedure, is the SS total over n minus 1. Okay, so here we are told it's 14. That is SS total over 25. Okay, so multiply that out, you get SS total, or solve that, SS total is 350. Okay, so let's put that back into our table. That's just a sort of blank page there. That's 350. So that's that part used. Now the coefficient of determination is 0.90. Okay, so what does that mean? So we know what SS total is here. I'm just going to get rid of the rest of this stuff here. The SS total is the ratio of SS regression to SS total. Okay, so that is R squared equals SS regression over SS total. Okay, and that is 0.90. Let's get rid of that as well, so we know what that is now. That is 0.90 equals SS regression over 350. You can work that out. SS reg is 315 by my calculations there. Okay, so it's 315. Necessarily the other one is the 315. Okay, now for the sum of squares for error is just the difference of the two. Okay. It's also implicit in that for information. So the ratio is whatever's left here. So if it's 90%, the other ratio is 10%. Likewise, if it was 95%, it would be 5% and so on. So now we are going to calculate the mean squares. So what we have to do here is the mean squares, as always, are the sums of squares divided by degrees of freedom. Okay, so this is 315 divided by 3, and that is 105. Okay, the next one is 35 divided by 22. A little bit of calculator work, and I don't have my calculator here. I just dropped it. Pause for a second. It is, sorry, I just paused it there, so there might be a lag there. So I'll just start again. 1.59 is 35 divided by 22 is 1.59. Well, 1.59 will do us here. Now, finally, the F ratio is, or the F test statistic is these two values, is the ratio of these two values here. So 105 divided by 1.59, and that is 66.03. So we'll just use two decimal places, 66.03. So that is the entire table taken care of. We're not actually, you're not required to perform a hypothesis test. But just to state that this is the test statistic, I'll just go to a new page here. Test statistic is F random variable. That's a type of distribution, the F distribution. But what is the important thing to sort of finish up on with 3 and 22 degrees of freedom. Okay, that's a sort of important matter, just to dovetail with finding the value in the critical value in a statistical tables or something like that. Or in some procedures, you might actually just be given a p-value just there, and that's the end of it. Okay, that's just a sort of important little remark there for any dovetailing with pen and paper procedures or the pen and paper procedures. Okay, that's regression ANOVA.